Okay, we're going to do projectiles launched at an angle, and we're going to do D5. All right, so first we're going to read the problem, and remember, we're going to chunk it. Whenever you do a projectile, you really need to have a picture. So it says a golf ball is hit at an angle of 45 degrees. So in our given, we know that theta is equal to 45 degrees with the horizontal. If the initial velocity is equal to 52, so VI is equal to 52 meters per second, how far does it travel horizontally before striking the ground? So we want to find x. And that's also called the range. So the first thing I want to do is I want to draw a picture. Here's the ground. The initial velocity, VI, is equal to 52 meters per second. And then it's going to take a path like this, and it ends up hitting the ground at the same level in which it's launched. The first thing I'm going to do is I'm going to write my given, but I'm going to separate my given into x and y. The first thing that I'm going to write on every single problem is AX is 0. There's never any horizontal acceleration. And G is equal to negative 9.8 meters per second squared. That's never going to change either. This is my frame of reference. This is where I'm starting. Remember, my frame of reference is where motion begins. And my sign convention I'm always going to use is up and to the right is positive. Now, if I am given the initial velocity, which I am in this case, the next step is I will break my initial velocity up into horizontal and vertical components. So my initial velocity like this is 52. So that's, and then to find the horizontal and vertical components from where I start, I'm going to go like this. And then from here, I'm going to go like this. So VIX, and this is my angle here, theta, which is 45 degrees. Oh, for 45 degrees, the sine and cosine are the same. So this, VIX, is going to be VI cosine of 45, which is going to be 52 cosine of 45. So when I put that in my calculator, this is how I'm going to do it on this calculator. I'm going to press 45 cosine, which is 0.707, which you should know from math class, times 52 equals, and it says 36.76. So I'm just going to write 36.8. Now, because sine and cosine of 45 is the same, I know VIY is going to be the same. So now I'm going to write this in my given. VIX is equal to 36.8, and VIY is equal to 36.8. And that's only because it's a 45-degree angle. Now, what do we do next? We know we want to find x. So the problem is that we always know we need to have three things on one side. Let's say you have no idea what to do. When you don't know what to do, you go to the end. So I want to find x. So I know x is equal to VIXT. And if you remember before, the 1/2 AXT squared, this is always 0. So this is our equation. So when you don't know what to do, you go to the end. And I want to find x. I have VIX, but I don't have t. So this tells me if I find t, then I can find x. So that tells me what to do next. But I'm looking, and I'm like, gosh, I don't know anything else in this problem. Now let's look at this. This is where I start. This is where I end up. Am I at the same level that I started from? Yes. So y is equal to 0. From where I start to where I end up, the vertical displacement is 0. So now I have three things. So I have little g, I have VIY, I have y, and I want to find t. Now, is there an equation that has these four variables in it? There is. The equation is y is equal to VIYT plus 1/2 GT squared. The problem is VIY is not 0. So if I substitute in my values, I got 0 is equal to 36.8t plus 1/2 negative 9.8 t squared. What happens here? I have a t and a t squared. Mathematically, to solve that, I'm going to have to use the quadratic equation. Do I really want to use the quadratic equation in physics? I can. But on the test and the quiz, you're not going to be using a calculator where that has that programmed in it, like your graphing calculator, right? So there's more than one way to do it. So you can either use the quadratic and solve for it, okay? Because this is physics, when you use the quadratic, you're going to get a positive and negative value. So if I factored out a t, because this is 0, I would get a positive and negative root. So if I did that, in physics, it would be correct, because in physics, the time is equal to, time can only be positive. So I could do that and get the positive value. So if I factored out a t and said 0, you can't do this in math class. It's 36.8 minus 4.9 t. I could rearrange that and say 4.9 t is equal to 36.8 and then solve for t. Now, I don't recommend doing this. I'm going to show you how to do it, which is the correct way to do it, where you're not doing that. So what happens is, here's my projectile. This is VI. This is VF. Now remember we said that the horizontal component of the velocity never changes? Remember when we looked at the equations? So here, when I look at this, VIX is going to be equal to VFX. The only difference here, because we don't take air resistance into consideration, what did I do here? The arrow goes this way. So this is VIY, and then VFY goes down. So this one goes up and this one goes down. So basically, the velocity, because we don't take air resistance into consideration, is the same. The only difference between VIY and VFY is they're equal in magnitude but opposite in direction. So VFY is going to be the same as VIY, but it's going to be negative. So now, if I have VFY, I have VIY, and I have G, I can find T using another equation. So that's how we're going to do it. So we're going to say VFY is equal to VIY plus GT. So VFY minus VIY over G is equal to T. So VFY is negative 36.8 minus VIY, which is 36.8, divided by negative 9.8. So then when I do that on my calculator, I get 7.5 seconds, exactly the same thing I got for the time here. So here's the things about physics. A lot of times when you do a problem, there's more than one way to do it. What is the best way to do it? The best way to do it is the way that you understand it. So if you're okay with the quadratic and you don't mind doing it, or you say, okay, I can factor out a t, you can do it that way. Now this you can only do where this is 0. You see what I'm saying? So this is the best way to do it, because no matter what, when you do it this way, you're doing it correctly. But we're not done with the problem. The problem says find the displacement. So again, x is equal to Vixt. So x is equal to Vix, which is 36.8 meters per second, times the time, which is 7.5 seconds. So x comes out to be 276 meters. So with projectiles launched at an angle, this is only a special case. This is the case where it lands at the same level at which it was launched, but that's the only ones that we're going to do in this class. We're not going to do ones where it lands at a different level, okay? But for today, that's all we're going to do. So you need to draw a picture for every problem. And now what we're going to do is the homework problems, the other ones, instead of them giving you VI, they're going to give you how far it goes X. They're going to give you this, okay? And then maybe they might tell you something else, like they might tell you the maximum height. So in a case like this, if I asked, once I found the time here, the time it takes to go from here to here is the total time. If I asked you the maximum height here, this maximum height is going to occur in half the time because there's no air resistance. So if I found that the time was 7.5, if I wanted to find this maximum height y that occurs here, which would be halfway, I would use the same equation. Y is equal to VIYT plus 1/2 GT squared, but I would substitute in here half the time because this maximum height is going to occur halfway. Okay, so these are some of the things that we're going to see as we do the homework problems. Okay.